Tonight's program is about something we all experience nearly every day and likely talk about multiple times per day. This still works. Sometimes they ruin our plans, and once upon a time, they captivated our daydreams. Despite their constant presence, most of us don't really contemplate them very often. Tonight, we'll be discussing clouds, the sky ones, not the phone ones. Our presenter this evening is Gavin Pretor-Pinney, the founder and member 001 of the Cloud Appreciation Society. Sherry, do you know your member number? 44,000 something. The society has more than 60,000 members across 120 countries. So if you're not a member, get on board. He is the author of the internationally best-selling Cloudspotter's Guide, The Cloud Collector's Handbook, and A Cloud a Day. Our good friends, Hey Allie, at the Bookworm are back there with one of his titles that he'd be happy to sign for you after the program, if you wish. He's the winner of the Royal Society Winton Prize for Science Books. He's a TED Global speaker with more than 1.3 million views. He's presented television documentaries for the BBC and Channel 4 and is a visiting fellow at the Meteorology Department of Reading University and winner of the Royal Meteorological Society's Michael Hunt Award, which I feel like I need to have a British accent to say that one. On our initial phone call, Gavin said something that really caught my attention. He said that most of us spend most of our time looking down at our toes, at the street, at screens, unfortunately, all too much. Cloudspotting presents the opportunity to look up. Ladies and gentlemen, please welcome to the Vail Symposium stage, Gavin Pretor-Pinney.
Thank you, James. Thank you so much. Thank you. Can you hear me now? Yeah? Great. Thanks so much, James. And again, thank you, Sherry, for bringing me here. Sherry is a member of the Cloud Appreciation Society, and I'm going to tell you a little bit about the Cloud Appreciation Society. This is generally, though, going to be about our atmosphere. It's going to be a guided tour of our atmosphere. I'm going to start low, and I'm going to go high as you can go. The society, however, is a collection of people around the world in 120 countries, as James said. People who share the belief that the sky is not to be thought of and the clouds are not to be thought of as just the things that get between us and the sun. But they are, when you stop to think of it, one of the most evocative and dynamic, maybe even poetic aspects of nature. And that there's a funny thing. Because the sky is always there above us, constantly taking up half of our vision, it's really easy to miss it. It's so there in our faces that it's hiding in plain sight. And you really have to remind yourself, in a way, to look up. Maybe tap yourself on the shoulder every now and then and remember to pay attention to whether there's anything going on in the sky, because the sky is an ever-changing, ever-present backdrop to our existence, like a abstract art show going on above. So as we go up through the atmosphere, I'm hoping to lift your perspective on the sky at the same time. But before we get started, since we are in this cloud spotting for beginners mode, I thought it would be a good idea for a little animation, a 1-minute animation, so we can all get to understand how clouds work. All right? Just summarize it very quickly. I did the voiceover for this animation, and I did it in the style of one of those 1950s government information films. I just thought it'd be more fun like that. But it's with the English accent, so it may not resonate in that way with you guys. Anyway, here it is. This is how clouds work.
Welcome to the world of clouds. Before you start collecting them, let's explain what clouds are and how they get up in the sky. It all begins down on Earth. As water evaporates from oceans, rivers and lakes, its molecules, which are far too small to see, lift up off the surface. cools enough, they start to stick together into droplets or ice crystals. Millions of these, suspended in the air, appear as a cloud. The low clouds, like cumulus, are made of droplets. The high ones, like cirrus, are made of ice crystals. No two clouds are ever alike, but they share characteristics. Sometimes they're in translucent streaks, sometimes clumps or stacks, and sometimes layers. As the particles of a cloud scatter the sunlight, they can cause a whole range of different optical phenomena to appear. When a cloud grows tall, its base appears dark, and the droplets in its upper reaches can start to freeze. Soon they grow large enough to fall. If the air below is warm enough, they melt as they descend, land as raindrops, and the whole cycle begins again. Happy cloud spotting!
Right, so that's how they work. Thank you very much. So we're going to start from low down. And what is the lowest cloud? Well, of course, it's fog. It's the one cloud we can walk within. So perhaps we're most intimately have experience of fog. It does have an official name, stratus. Latin alert. We may have a few Latin words coming up this evening. Generally, though, they just mean what the cloud looks like. So stratus is a Latin for a layer or a blanket. And it is the cloud that sometimes collects in valleys. And if you're looking down on it, it can have a ocean-like feel. It can be like an ocean of clouds, especially when you see the undulations of it travel across the cloud like it does when you see it in time lapse. But stratus, this low cloud, doesn't have to be actually at ground level. It could be up a little off the ground. For instance, covering the tops of hills or mountains. And that would still be stratus because it refers to any low blanket of cloud, indistinct blanket of cloud. Or perhaps if it is over a city, stratus would be the sky that skyscrapers scrape. The tops of the buildings disappearing into this low layer. And I was interested to see that stratus, it may not be the most sort of arresting or beautiful of cloud formations, but I think it's the one that stars in the first realistic depiction of clouds in art. And this is before people were doing realistic clouds in Western art. In the early art of China, the Incan scroll paintings, you have a whole bunch of them themed on the interaction between mountains and fog in the valleys. So you can see down there, this is 950 AD, down there in the valley, the fog, it really looks quite realistic the way that it is kind of half hiding some of those trees. The buildings are kind of half in it and half out of it. Really quite realistic before, like I say, anyone was doing anything realistic in the cloud art of the West. And then you can see also up there on the slopes of the mountains. Will my pointer work? I don't think it... Oh, there it will. Up there on the slopes of the mountain there, you see there are fragments of stratus clouds. And here, look, we can take stratus, that's the main cloud type, and you can add a word after it. Fractus. That means like a shred, a torn bit of stratus. So you can add these terms to add clarification. And you see this in reality on the slopes of hills or mountains sometimes, fragments of what are like stratus clouds. I love these early Incan scroll paintings because of how faithfully they were reproducing the interaction between clouds and mountains. And as you guys all know, there's a love affair between clouds and mountains. The air streams over mountain peaks cause cloud formations to appear. The wind flows in the lee of the mountains, shape different cloud formations into beautiful arrangements, and we'll come to some of those later. But in this one, I was rather fascinated about something I think most people have missed. If we zoom in a little, you might see there we've got the fog down in the kind of valleys of this mountainous region. To zoom in a bit further though, and what's going on up here? You might only barely be able to see it, but if I increase the contrast, it looks a bit like a breaking wave. Do you see that? A little bit like a breaking wave. And that immediately caught my attention, because I've seen breaking waves in clouds, particularly sometimes over fog. It's a feature known as fluctus. Fluctus cloud feature is when a bit of a cloud looks like a breaking wave, curling over in a kind of vortex. You see this sometimes along the top, very occasionally. I say sometimes, very rare. Along the top, if there's a breeze blowing across the top of some fog, it can cause some undulations to develop and maybe pick up some of those undulations. You see fluctus higher in the sky as well. These features don't just form down at the stratus or fog layer. And you can see them right up in the high clouds too. Fluctus. They're caused by the wind pattern, a particular wind pattern. Here's your wind, and the wind where the cloud is slower than the wind just above the cloud by quite a lot. So you get this sort of difference in wind speeds. It's called shearing. It's a shearing effect, shearing winds. That sets up undulations in the flow in between, this ruffling effect. And if the difference in wind speeds is just right, the tops of those undulations curl over in these beautiful vortices. They're only in the sky for maybe 3 minutes before those beautiful formations break up and dissipate. The cloud breaks. And they're quite rare, but I did see some on my flight over from Missouri, where I was speaking. I've done a few talks on this trip, and I did one in Missouri, and I looked out the window and I went, that's got to be a good sign. There are some fluctus clouds in the sky outside. Always a good sign. And you can see this shearing. Well, you can't really see the shearing, but you can see the way that the clouds in time lapse do kind of curl over a little bit like a breaking wave. They don't really splash down like a wave at the shore, but there's a curling effect to these vortices. And a bunch of these time lapses you'll see that I'm showing you were sent in by Walt Lyons, one of the members of the Cloud Appreciation Society, who kindly contributed a bunch of his time lapses. But all of these photos, or most of them, are sent in by members of the Cloud Appreciation Society from around the world, so I'm always grateful to them. You will find this shearing wind effect often happens over mountains. So keep an eye outside, because you're in a good place to see them. And the reason they often form over mountains is because the airflow that's nearer to the terrain gets interrupted. You know, there's friction with all those mountains and raised ground. It gets slowed down, whereas the wind higher up goes on unimpeded. So you get this real distinct difference in wind speeds where the cloud is, and that can cause these beautiful undulations to develop. So, yeah, I love the fact that who was hiding in the background of that particular painting. And I always love it when faithful representations of cloud formations appear in art. That was one of our 10 main cloud types. I'm not going to go through all 10 of them, but that just happens to be the lowest one, the stratus. There are 10 main types of cloud, and this is one of them, the stratus cloud. And here is another of the 10 main types of cloud. It is, of course, the Simpsons cloud. No, it's not. It's got a Latin name too. And I'm wondering, I mean, we can call it the Simpsons clouds if you want, but I'm wondering if anyone here would like to put their hand up, if they might have half an idea as to what type of cloud. Down at the back, I see a hand up. Shout it out. She says, is it a cumulus? Absolutely right. It is a cumulus cloud. Oh, someone else putting their hand up. She's got it right.
Well, fair weather cumulus.
Fair weather cumulus. Oh, very fancy. We've got some fancy answers in the back there. Absolutely right. This is Cloudspotting for beginners, remember? So, well done. Can we just give a round of applause for the cumulus answer there? You would be very pleased to learn you've won something for getting the answer right. What have you won? You have won our cloud spotting chart. Shows all the different types of clouds. There you go. You can geekily go through them all, look for different types, and next to it, the little long strip where you can check them off as you spot them. There you go. Oh, I just passed this down. You're welcome. Well done. Right, yeah, so cumulus cloud. There it is, next to the stratus there. And it is another low cloud, but quite different in appearance. Stratus was this indistinct blanket. Cumulus were they're kind of like individual clumps. And when you see these fair weather cumulus in the sky, they look very solid. They really look like things, all right? Solid things. They've got crisp outlines. They're bright white. And that's because they're made of lots and lots of tiny droplets of water. And if you've got lots of droplets of water, they scatter the light very effectively. And that's what makes it look bright. Or on the shadowed side, look dark. It makes it look solid. And that's what the Latin word means. A stack or a heap of something is where we get the word accumulation, same root. And so they're solid looking clouds. And everyone loves a cumulus. I mean, who doesn't feel fondly about a cumulus cloud? They're the most light-hearted, I guess, of the cloud formations because they form on a sunny day. And the fact that they've got crisp outlines makes them particularly good for finding shapes in. All right? And we all feel maybe a sort of nostalgic affection towards cumulus clouds because perhaps when we were kids and we had like no deadlines but bedtime, we used to just sit on our backs sometimes and look up and see shapes in the clouds. You know, we've all done that at one time or another, and they are generally cumulus clouds that will be good for finding shapes. And we love it when members of the Cloud Appreciation Cloud Appreciation Society send in clouds that look like things. This is not just a pastime of adults. It should be one that we encourage in ourselves every now and then, because it is forcing us to be a bit more playful and to engage with the sky in that positive way. So I love it when someone sends in a heart, a cloud in the shape of a heart, or maybe a cloud shaped like a bunny on a roof, or a bunny in the hedge. A cloud of someone falling over, or perhaps an elephant, not an elephant, a dog. It's a dog, what are we talking about? Or a cat. This isn't really a cumulus, it's little, like, got a bit more of a mature cloud, this one, but it's looking down on the traffic in a rather pounce-like way, like it's about to pounce on the cars. Or maybe an elephant, someone might see an elephant in the sky. This one's here over Yosemite National Park, and here's an elephant over Phuket in Thailand. And here's an elephant over Myrtle Beach, North Carolina, up on its hind legs, trunk in the air. Here we've got an elephant squirting water. And here we've got a pink elephant. We get a lot of elephants sent in. In fact, of all the animals that people see as shapes in the clouds, elephants are the most frequent. I can say this because we've seen a lot sent in over the years. 18 years was when I started the Cloud Appreciation Society. I've seen a lot of animals in the clouds sent in, and I can categorically say that elephants are the most frequent of all the animals. What is that? What's that about? It's not just from one country, from around the world. And when you start to think about it, or start to look into it, you see elephants associated with clouds in culture. So you might see it, like this is a dish from Vietnam in the 15th or 16th century. And there we've got in the middle elephant surrounded by clouds. Why would they do an elephant in clouds? They don't know that the Cloud Appreciation Society members send a lot of elephants in. We all know about Dumbo, and we might know about myths, Indian myths, early Hindu myths, where elephants were involved with the creation of the world. White elephants who could fly and could change shape and had the power to bring rain. Clouds, basically, clouds. And they also, when they would pray to albino elephants, early Hindus would use this term mega, which is, I think, that understand is the term for a cloud. So there's a long association with elephants and clouds, and I think it might be because of the science. Here is how a cumulus cloud forms. Let's look at a lava lamp. In a lava lamp, you've got the lamp at the bottom, and you've got a mixture of wax and water, and the wax has been very carefully chosen to be a little bit denser than the water at room temperature. So it sits down at the bottom, sinks to the bottom. But when you turn the lamp on, it starts to warm, and it starts to expand gradually, and then become less dense than the water and start to float upwards, until it cools up at the top and starts to come back down because it becomes more dense again. So it expands, goes up, contracts, comes back down. Same thing is happening outside on a sunny day, but rather than liquids, of course, you've got the gases of the atmosphere. And the sun is heating the ground, and the ground is acting like the bulb, which warms the air in contact with it. One bit of the ground, like this bit of ploughed field right here, will warm the air more efficiently than this bit of woodland here, or a parking lot might. And that starts to expand and rise quicker than the others, and you get individual thermals of air, invisible rising air lifting off the ground, off the sun-warmed ground. And as that air rises, it expands, because you're going up through, it's like the pressure difference, it expands. When any gas expands, it cools. Okay, so when a gas expands, it cools. That is why clouds are always associated with air going up. So the air is rising in an invisible thermal. You can't see the thermal, you can just see the top, where the air has cooled enough for some of this invisible gas form of water to condense into droplets, which we see as the cloud. So that's how a cumulus cloud is born. It's born on the top of a thermal. And this is why I think maybe there's an association with elephants, because the thermal is this rising column of air that drives the uplift or growth of the cloud. These cumulus clouds are staying quite shallow. They're not growing very tall because we're in high pressure, fair weather. But if it was growing a taller cumulus cloud, you would have this central column rising, and then as the cloud dissipates, that center where the thermal was is the last to go. So you have a kind of trunk sticking up in the sky. I think that's it. I think it's the science, and that's the Hindu myths. I think it's all based on the science. We see elephants in the clouds. It's a guess, but who knows? That's the way I'm saying it. All right, so let's go up a little into the mid-level clouds. And we are talking the mid-level, not of our whole atmosphere, but of the part of our atmosphere where weather happens, which is called the troposphere. So we divide that into low, middle, and high. And we don't really get too excited about actual altitudes, because the height of the troposphere at the poles is maybe only 6 miles or 5 and 6 miles. The height of the troposphere at the equator might be 12 miles. So it's all relative. It varies depending on where you are around the world. Mid-level clouds, like this one, starts with alto. All right? And alto stratus, well, it's like a kind of higher version of a stratus. All right? There's an indistinct layer a bit higher up in the sky. Hands up, anyone who might have an idea what therefore this one might be called. Yes, Mr. Expert Cloud Spotter, yes? No, I'm so sorry. It was going so well. Yes. It could not be. It's nice try. Yes. Alto cumulus. I like your logical thinking. Altocumulus is absolutely right. A round of applause for Mr. Altocumulus, please. Because it is in the alto, the mid-level, and it's a clumpy one, so altocumulus is absolutely correct. See, logical thinking, that's what it's all about. You have won. You have won. None other than our cloud selector. This is one of those, this is the app before apps were invented, all right? You know, this is how it used to happen. No Wi-Fi required. No batteries to run out. There you go. Shows you the different types. There you go.
Thank you very much.
You're very welcome. Yeah, so the altocumulus cloud. These ones are higher, mid-level clouds, and they have a solid appearance to them. All right? So that's the cumulus part. Anything that looks kind of, any cloud that looks kind of solid and well has defined edges to some degree, but it's quite different from the cumulus down below. This one is, those kind of clumps or masses, they're smaller, aren't they? Smaller than the cumulus were. But actually, they're not really much smaller. They're just, they're higher, and therefore they look smaller. If you were to get up in an aircraft, as we often do now, and go up and look out the window at these altocumulus clouds, well, they probably appear about the same size as they do down below. And that's what Georgia O'Keeffe found when she did her series of paintings of cloudscapes based on the views from the window of an aircraft. So it's not only, so they're just further away. That's why they look smaller. But the other thing that's different about them is they're arranged into this really regular pattern. That feels quite different from those cumulus, which are more kind of lone clouds. They do their own thing, individuals. These are more like a kind of tiled mosaic of clouds when altocumulus are in this sort of appearance. And why is that? Why would they appear so regularly like that? I want to demonstrate this to you with the help of a panini toaster and some oil. All right? Here you go. Here we are at my desk. It's a basic old panini toaster. And I say old, it is a bit of a kind of manky old one. And what we're going to do to represent the movements of the air is we're going to use some vegetable oil. For us to see the movement of the vegetable oil, we need something in it. It's got mixed in with it some powder. It's called mica powder. It's like a powder that people use in crafts and stuff like that, sort of sparkly, and is going to show you the movements. It sort of renders the movements of the oil visible, and that is going to be crucial for us to be able to see what's going on. You may be wondering, what has this got to do with the sky? Well, what happens is up in the air, you can end up with a region of warmer air beneath a layer of colder air above, and the warmer air wants to float up because it's less dense than the colder air above, which wants to sink back down. Now, you can't replace one layer with another layer just like that, because one's got to get up as the other's coming down, so it arranges itself. And I'm hoping the same thing is going to happen with the oil. It's going to arrange itself into sort of cells that go up and down. Here we go. First off, I'm going to pour in some of this vegetable oil. There we go. So look, I'm just going to wodge it around a little bit. I'm going to now lean over and plug in the panini toaster. So the element within here beneath is starting to warm, and that is starting to have an effect. Now look, what's going on there? What is going on there? Compare that to the cloud. That oil has arranged itself into parts that are rising and parts that are sinking, because it can't all go up. You've got the warmer oil below, wants to float up and replace the colder oil above, but it can't all go up in one go. It has to
arrange itself into rising and sinking parts. And that is precisely what happens up in the sky when an altocumulus cloud looks like that.
So so that's sort of, why they arrange themselves. They're away from all the chaotic movements of the air down near the ground, because it gets in the way, the old mountains in the way, or a building, or thermal coming off the ground. It just gets messed about down here. Up in the altocumulus level, the winds are a little bit more sort of laminar, and so you can get these patterns developing, this self-organizing. Not all altocumulus clouds have that kind of patterned mosaic appearance. Sometimes you can get an individual solid-looking cloud in the mid-level of our atmosphere, which looks, well, like a sort of UFO. This is still an altocumulus. We've added the term lenticularis to the end of it. That is the Latin for a lentil, a small lens, which the Romans would use to refer to a lentil. And it should really be the Latin for a UFO, but nobody knew the Latin for a flying saucer, I guess, because these really do look like there's a kind of alien invasion happening. You got to see these around. Do you see these around here ever, these lenticular clouds? Yeah. They are mountainous clouds, mountain-related clouds, as I'll explain in a little moment. I lived in Rome for 8 months, and when I was living there, I did a little trip to the town of Arezzo. And when I went into the basilica in the little town of Arezzo, I looked at the frescoes on the wall by Piero della Francesca, and I went, wait a minute. Look at those clouds up there in the sky that Piero della Francesca painted in his paintings. Not your average cartoon cumulus clouds, which is what a lot of artists around this time might have painted if they bothered to paint a cloud, because quite often at this part of the Renaissance there were no clouds in the sky, just blue skies. But this guy, Piero della Francesca, in the 15th century, he chose lenticularis clouds, very, very specific. They were in all of the frescoes in this basilica. In fact, they were in pretty much all of his paintings. He loved these clouds. He was an early cloud spotter. A posthumous membership should be awarded to him. And I think the reason perhaps why he decided, I'm going to put these clouds in my paintings, not the ones that everyone else is doing, is perhaps because he grew up at the base of some mountains in Italy, the Apennine Mountains. So I like to think, based on zero research and zero actual evidential basis, I like to think that he maybe used to look up at them when he was young and see these disc-like clouds in the sky and think, one day I'm going to be a famous artist, and one day I'm going to put lenticularis clouds in my paintings, and one day some guy will start the Cloud Appreciation Society and he'll mention them. That's what I like to think he thought, because these clouds form around mountains. They form downwind of mountains, and here is why. You have this wind hitting an enormous obstacle, which is the mountain, and some of it will go round, sure, but some of it has to fly up and over the mountain. And when we're in stable atmospheric conditions, by which I mean not stormy weather, that air kicked up in the lee of the peak beyond it will sink back down again. It wants to return to equilibrium. That's the stable conditions. It goes up, sink back down, but it overshoots and comes back up, and you get this wave pattern, this wave path. It's known as a standing wave because the air's flowing, but the position of the wave is fixed relative to the mountain. And you can see this isn't like an extended lenticular effect rather than a single disk of cloud, but you get the idea of this sort of flow, but the position where the cloud starts is fixed. Here it's a bit clearer. In side view of one of these lenticularis clouds, a kind of stacked example, sometimes they're stacked up, you see the cloud forms at the front, and it sort of, the droplets of the cloud go through with the wind, and then it sort of dissipates at the back. And that's because the air rises at the peak, of this flow, and as it rises, it expands, and it cools, and a droplet or many droplets form. They rush through with the wind until the wind sinks again. It warms, and they evaporate. So they're flowing through, but the cloud's position is fixed. And it's a little bit like a stream on a boulder in a stream, and the water's flowing over the boulder, and the flow of the river is constant, but the wave shape just downstream from that boulder is fixed in position. That's a standing wave, and that's the sort of wave that forms these lenticularis clouds. The wind is strong, the cloud stays still, hovering in the sky like a UFO, come from outer space to remind us that clouds, they are the vehicles of the imagination. Sometimes they're stacked up like this. Pile d'assiette is the French term, a stack of plates, used when lenticularis clouds have this stacked appearance. It's when the wind flow has moisture and drier layers, has this stacked effect. Sometimes the waves extend out across the sky and you get this dramatic expanse of more like lozenges joined together. One of my favorite cloud formations. You guys should be spotting them in the winter time, hopefully. Maybe when there's a weather front on its way. You do need to be downwind of the mountain, so it all depends which way the wind's flowing from where you are. Keep an eye out for them. Let's go a little higher. Any ideas? Hands up. You would put your hand up right away, down at the back there. Cirrus. The cirrus cloud, absolutely right. Round of applause, please. You have won our embroidered patch set for your school bag. Put it on your school bag. Okay. Right. Yes. The cirrus cloud, we're now up to the high clouds. And the high clouds are not made of water droplets like those low ones were. These are made of ice crystals, falling, cascading from the upper reaches of the troposphere. Those middle clouds we saw of the altocumulus type ones, those could be ice crystals, could be water droplets, are most of the time a mixture of the two. Can't quite make up their minds, changing. But these cirrus know exactly who they are, and they are high ice crystal clouds, and cirrus, the name means in Latin a lock or a curl of hair. That's what cirrus means, a lock or a curl, referred to the hair. And so these are like streaks of hair across the blue, and they might be combed out, straight hair, combed out by the high winds, all smart and ready to face the world. Or they could be curly hair. These are different forms of cirrus, and each have got their term that you could add after the main cloud type. In tortoise means twisted for curly hair. So this is when the winds are not flowing in a straightforward direction. The shape of the cirrus cloud streaks is to do with the way the wind changes as the cloud falls. Because if it falls into slower winds, it might go like that, and then speed up again, it might go like that. So you get this wavy effect because the change as the ice crystals fall. And sometimes they're in this hooked formation, cirrus uncinus, Latin for a hooked cloud, or Latin hooked is what uncinus means. And these are the mare's tails that tell ships to carry low sails, because these can be associated with weather changes in store. They can be associated with the arrival of a weather front. And what they indicate, that hook indicates shearing winds again. And that, if you remember with the fluctus clouds, was when the wind speed differed considerably with altitude. So it could also be wind direction, like that. Could be like this above and like that below. But there's a marked difference. And here you can see some cirrus uncinus with these definite hooked sort of appearance to it. It looks a little bit like the wind is flowing that way, right? Across that way. But actually it's not. It's going that way. And the reason why they have that hooked appearance is the ice crystals fall from the faster winds into the slower winds and trail behind as they fall. And that gives it the hook. And the hook tells you there's a sudden change at a certain altitude. That associated with moisture up in the high atmosphere. Those are sort of things that happen ahead of a weather front on its way. So that's why mare's tails invading the sky. They've got to be spreading and spreading. If you see those happening across your sky, they're an indication that you might have a weather front coming, perhaps some rain in a day or so, or maybe 6 hours or something like that. The favorite cloud of Edward Hopper, cirrus clouds. I love seeing how different artists we all saw Piero della Francesco in his Lenticularis. Edward Hopper, another posthumous member of the Cloud Appreciation Society, clearly liked the high cirrus clouds in his ones. So we've got a number of these different cloud names. We've got a few more there. We're not going to go through them all. But I want to talk about that one on the right-hand side, the big one. Can I see any hands going up of what this one might be? Say that again. Could you turn that the other way around? Yeah, cumulonimbus, did you say? Yes. It is indeed a cumulonimbus cloud. A round of applause for Mr. Cumulonimbus. And you are, yeah, what did I win? What you won was our 2024 cloud calendar, hot off the presses, just come back from the printers. You're very welcome. Much better than the 2023 calendar at this time of year. All photographs sent in by our members from around the world. The cumulonimbus cloud is the mighty royalty of the cloud world. This queen of clouds stretches from right down in near to that stratus or cumulus level, right up beyond the cirrus cloud level to the very top of the part of our atmosphere where weather happens. And it spreads outwards at the top in this distinctive, it looks a bit like a mushroom, but actually we describe it more in terms of an anvil. I'll show you why in a minute. But this is like an expression of the architecture of our atmosphere. It gives a real 3D quality to the atmosphere that some of the other clouds don't, and which you certainly don't get from a blue sky. It is the storm cloud. Produces hail sometimes. This spreading out at the top, all right, that tells us something about the troposphere. Here's why it's described as an anvil, because it extends one way more than the others. So it's like an anvil sticking out. Blacksmith's anvil, the other word for it is incus in Latin, which is the Latin for an anvil. Blacksmith's anvil. So you've got it extending out in one direction. This one does sort of have these bits kind of punching up there in the middle, and that is known as an overshooting top, because this really is the top of the cloud. It's almost like it is formed underneath an invisible sort of piece of glass or something like that, the way it's spread out like that. And effectively, in atmospheric terms, that is what's happened, because the top of the troposphere, that part of our atmosphere where weather happens, there is a lid on the growth of clouds, an invisible lid that is to do with the temperature. Because normally, when you go up through the troposphere, you get variations, but on average, it gets colder, 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 as you get up to the top of the troposphere, when suddenly it stops getting colder, and in fact, it starts getting warmer for a bit. And that is called the tropopause, a pause in that coldening pattern, and it acts like a lid. So any cloud that's growing up taller and taller, like this enormously tall cloud growing maybe 10 miles up into the atmosphere, perhaps 12 at the equator, this can't grow any higher. And so it can only spread out into underneath this invisible ceiling. And that's why the storm cloud has that kind of mushroom-like kind of pattern to it. It is also the cloud that produces thunder and lightning. It is an expression of the power that drives our atmosphere. And when you're down beneath the cumulonimbus cloud, it is very different from seeing it off in the distance like that. No longer does it appear like a like a kind of royalty of the cloud world. It's more like a monster. It's more like a beast when it is maybe throwing hail down on you. Each lightning bolt is a redistribution of the electric charge that can develop within these huge storm clouds due to all the collisions of the particles within. So if you're living somewhere very arid, these storm clouds, which produce heavy showers, localized showers, in one bit over there or over there, sudden and strong, and with a massive fanfare, you're going to be paying quite a lot of attention to them, aren't you? It'll be pretty important to you. So it's no wonder that when you start looking at the rock art, the petroglyphs and pictographs across the whole Colorado Plateau, you start to see clouds and rain clouds in particular appearing. These ones here were by members of the Hopi people, who different clans of the Hopi people would do pilgrimages now in what's now Arizona, would do pilgrimages to the Grand Canyon, and on the way they would stop at the rocks in Echo Cliff and carve different designs onto the cliffs, onto the rocks there, now known as Pretor-Pinney, and it's a protected monument. So one of the clans of the Hopi people at this time depicted a number of cumulus clouds with rain falling from them, a whole string of them across there. Nobody knows which clans depicted which designs onto these different rock formations. So historians and anthropologists and archaeologists now just refer to this group as the Cloud Clan. It's just the name that they use for them. Another early sort of bunch of Cloud Appreciation Society members, perhaps. And you also see in different people of the Colorado, different Pueblo peoples of the Colorado Plateau, different depictions of storm clouds. And I love seeing the different ways that storm clouds are depicted. And some of the other groups, not the Hopis, but some of the other groups depict the storm clouds as kind of animated beings with eyes and with kind of behavior. So we can see here on the left is a priest sprinkling sacred water and holding a prayer feather in its hand. And next to the priest is a storm cloud with showers falling down to the ground and wide eyes. The assumption is that that storm cloud is paying attention to whatever the priest is doing. These are all assumptions, of course, but the assumption is, by anthropologists interested in this area, is that there's a storm cloud supposed to be paying attention. A member of our society, Carol Patterson, who is an anthropologist, she used to work at the Colorado Mesa University in Grand Junction, where I spoke actually a few days ago, and she did her PhD on the cloud beings, as they're known now, of the peoples, historical, ancestral peoples of the Colorado Plateau. From 600, no one can very easily date these, and so with guessing 600 to 1250 AD, and here we have, by speaking to some of the elders of today, they can shed some light onto the meanings as well. And these arms stretched outwards thought to symbolize the sky, with a shower there, down between the legs of this cloud being. And you can see a storm cloud shower is localized off in the distance. It's kind of pretty similar. I love the way you have these kind of correlations here. Or maybe this cloud being, I don't know which region this one was. It's definitely from the Colorado Plateau, but I don't know which state, whether it was Utah like before. Here, the cloud being has not continuous trails of precipitation from it. They're kind of broken into parts, and if you look at the head of the cloud being, it's got these two antennae-like things pointing up, and the hands are outstretched, Carol's research has given us the impression that this is an indication of be aware or take notice or warning, those symbols. And the idea is that this is not rain reaching the ground, but is virga, which is the name for when precipitation falls, but the air nearer the ground is too dry and it evaporates before reaching the ground. So, when maybe these are symbols to say, be careful because it doesn't necessarily produce rain that you can use here, the clouds. So you also see beautiful symbolic additions, like there you've got the snake, which symbolizes, in some examples, symbolize lightning. You've got a messenger bird. You've got different cloud or precipitation only reaching a little bit of the way down and reaching all the way down in the middle of this cloud being. And you also have here priests performing various rituals to the cloud being, which has the rain falling from its arms and then lightning feet. And when you see a storm cloud, well, lightning feet kind of works, doesn't it? And sort of you can see why one might depict a cloud being with lightning feet. I love the way these different cloud beings have been depicted historically by the peoples of the Colorado Plateau. And it's fascinating to read Carol Patterson's work on trying to decipher them and catalog them. So any superstar of the cloud world, like the cumulonimbus is going to have an entourage of other cloud formations that like to hang out with it, go along with the crew. And one of those for the cumulonimbus storm cloud is the Arcus. It is this sort of low bumper or fender, which you can see there. It is just ahead of the part where the showers are happening. So this low ridge of cloud is like a 5-minute warning. Arcus means, by the way, a sort of arch, and these often look arched because of the sort of perspective as you're looking at it. It's a 5 or 10-minute warning that showers are about to hit you. When the low fender right above you, that canopy will be stretching out. But where the base of the cloud is coming towards you, that's often in a serious, strong storm. That is called the Arcus, and it's a 10-minute warning that the cloud is going to be with you in a minute. We won't be taking a flight in that plane right now. Also, features associated with these storm clouds are mama. These are pouches that form on the underside of that anvil. And these are, on the underside of the anvil, sometimes pouches hang down. And these can look incredibly dramatic in the setting sun at the end of the day. These mama features, when you see it in time lapse, they kind of push down. It's like a little bit like the opposite of that lava lamp. Within the cloud, the air cools dramatically, and suddenly it starts sinking into the air below and pulling down the base of the anvil with it. So you can see in time lapse here these kind of bulges coming down a little bit, and those would, if you look, they're sort of not moving like that, they would appear like those mama clouds, the mama features. So that was the mighty one that reached all the way up to the top of the part where that happens. But there are a couple of clouds that are a bit higher. In fact, one's a bit higher and one's a lot higher. This is the nacreous cloud. It forms not in the troposphere, but up in the stratosphere. And it is got these beautiful mother of pearl colorations to it, also known as a mother of pearl cloud. The nacreous is colored like this as a result of the way it affects the sunlight. When the sun is low in the sky, perhaps on the horizon, it can light up these high clouds, and its light is bent by the tiny particles, the tiny droplets, all very even in size, will bend the light as it passes around them, and this separates out the colors of the light to give it this beautiful wave-like pastel coloration to it. Why that they're known as mother of pearl clouds. That cloud iridescence, we call it, cloud iridescence of that you see in nacreous clouds. You do see it in clouds down below as well. I mean, just when Sherry and I were just walking up in the mountains, and the kind of hills earlier on. We looked at some beautiful cumulus clouds here the other day. I put near Vale. Where were we, Sherry, exactly? Yeah. Lake Creek. And yeah, but if you look at, can you just see just subtly around the edges where the cloud's breaking up, there is some color? Yeah, it's quite subtle. Sometimes it's a little bit less subtle than that and a bit more visible, but that's the same thing. That's cloud iridescence, and it forms when the sunlight shines through any cloud that has tiny droplets, which are quite even in size, and you often see them around the edges of cumulus where the cloud is evaporating away. Just the last remnants of that edge of cloud, the droplets have almost gone. They've got so tiny, and they're almost about the same size now. It's able to cause this diffraction effect and make the beautiful colorations appear. And it's exactly the same thing happens for nacreous clouds, just on a larger scale, so they get to be named after it. They're not the highest, though. The very highest clouds, come on, the highest ones in the sky are the noctilucent clouds. These form right up at 50 miles up into our atmosphere, right up towards the fringes of space. Noctilucent means night shining, because these clouds are so high. Here's the Earth, and here's the atmosphere, and these clouds are so high that when the sun has gone down over the horizon, the rest of the sky's dark, but it can still just catch these clouds up there, and that is why they shine out at night. You won't see them ever during the day. You will probably only see them maybe 11 at night after that, or maybe 2 a.m. in the morning. They only form in the middle of the summer, whereas those nacreous clouds only form in the middle of the winter, and you've got to be pretty at a high latitude, so you probably won't see them here, I'm afraid to say. But they're also known as polar mesospheric clouds, because these form up in the mesosphere. Here is a view side on from the International Space Station. There's the Earth. There are the noctilucent clouds, and here are some altitudes, and there's the troposphere. That's the bit where everything else was going on. That's where the enormous cumulonimbus clouds were, reaching right up. Well, they're only down in there. But we've then got the stratosphere, which had the nacreous clouds in it, and the mesosphere. That's where at the top of there is where the noctilucent clouds form. And there's outer space, so pretty much up on the fringes of space. We call that outer space. It just peters out, and you've got to say outer space is somewhere, so we tend to say it's about 100 kilometers. And noctilucent clouds are mysterious, beautiful, and seem to be appearing more and more frequently. So they're a bit of a mystery. So those names, or those Latin names for clouds, that's the system. But I like to think this system isn't fixed. It isn't finished, as it were. It was a system, this naming system, Latin naming system, which was first proposed by an Englishman from London called Luke Howard, who was a Quaker, and he lived in North London in Tottenham, and he had a scientific debating society which he used to go along to every now and once a month. They'd take turns for the subject, not so different from the symposium, except you guys are giving the talks. So he would do it once a month or something like that, and different people would take turns. He did one, and he said, I'm going to do it on the clouds and the naming of, I'm going to propose we should use Latin names for clouds like we do for plants and animals. We'll do it for clouds. And we use those scientifically. I know clouds are changing, so we'd have to do it a bit differently, but here's how I propose I do it. And he gave this lecture, which was very influential and ended up being the beginning of our naming system. He came up with cumulus, stratus, cirrus, and so on. And he did that, and our naming system in 1802, our naming system is still based on it. But here's why I think it's not fixed, all right? Things have been added to it over the years. A few years back, someone sent in a cloud like this to us, and we put it up on our website when someone sent in a cloud. Looks like waves, sort of crazy waves. I thought, well, it doesn't really fit in with any of the names we've got for naming clouds. Really? It didn't seem to quite fit in. And then someone sent in another one, and I went, oh, wait a sec, there's another of those weird wavy clouds. There is a term for wavy clouds, undulatus, but they tend to be more regular in appearance. These look chaotic and choppy, like the sea on a really busy, choppy day. And I was like, this is quite unusual. I keep on seeing these. Once you start looking for them, you see them everywhere. Every few months, someone would send one in from somewhere around the world, and it would be another example of that weird, choppy cloud. Sometimes they would have like peaks to them, like meringue peaks. And I thought, this is quite distinctive. Maybe we need a new name for this cloud. Maybe we need a new classification of cloud. And how do you go about coming up with a new classification of cloud? What do you do if you have a new type of cloud? Well, I thought you've got to go and speak to someone who's official, and you've got to have a Latin name. So as I thought, those are the basic 2 requirements. So I got in touch with the Royal Meteorological Society in the UK. I said, I've got a new cloud type. And they said, yes, of course you have. I bet you have. Yeah, let's have a look at your cloud type then. And I said, I'll bring it in. I'll bring in some photos from members of the society. And in the run-up to going in there, I thought, well, I need to have a Latin name. If I don't have a Latin name, they won't take me seriously. So I called up my cousin, Philip, who is a Latin teacher at high school. And I said, Philip, I need a Latin name for these clouds. They look like the sea on a stormy day. And Philip said, Glacialis Yemps Aquilonibus Aspirat Undas. And I said, Philip, that is not going to work as a name for this cloud. It's far too long for starters. He said, no. It is a Virgil quote. And this Latin poet Virgil, the quote means the waves were roughened by the icy winter's northern gales. Use that word roughened. There's a verb in there. Aspero, do something with that, maybe a noun or a verb based on that. Well, asperitas is a Latin noun meaning roughness. So, if Virgil used it to refer to the sea, that's good Latin. Said, always go to Virgil for good Latin. And the Royal Meteorological Society, when they had a look at it, said, well, that's pretty good. Looks distinctive. We like your cloud. We think there's a good argument for it. We like the name. Good stuff. But, we're not the people who say whether a cloud's official or not. You need to go to the World Meteorological Organization, because they are the official body, and they have the International Cloud Atlas. 100 years after Luke Howard named those clouds in 1802, and he came up with Cirrus and Stratus and Cumulus, 100 years later, they had the first International Cloud Atlas when the 10 main types of cloud were listed. Every 50 years or something like that, there might be a new edition of the International Cloud Atlas. It had early photographs and definitions of the different clouds. It still exists, and now it's run by the WMO, and they publish it. So they said to me, if your cloud's going to be official, it's got to be in the International Cloud Atlas, or otherwise you might as well forget it. Ain't going to happen. And I was like, okay, fine. And they said, but don't hold your breath, because it's the UN. The WMO, the World Meteorological Organization, they're the UN, and they don't do anything in a hurry. And I thought, well, it's not going to happen then. But the thing is, they kind of had their hand forced, because the media loved this story. One guy with his weird society has found a new cloud. It's got amazing pictures, and the World Meteorological Organization are refusing to accept it as a new type. I mean, that's a brilliant story as far as the media are concerned. And it kept on going through the media. It kept on coming again and again and again and again. They called up the World Meteorological Organization and said, so is it going to become official then? And again they said, no, we don't just change the system like this. It's been like this for hundreds of years. You'd have to put a whole new edition of the International Cloud Atlas out. And we've only just published one in 1974. So I thought, okay, it's not going to happen. But then eventually they got worn down, and they decided we'll do an online edition. And they invited me on World Meteorological Day on 2017 to Geneva to do a talk about clouds. You can see I'm a bit nervous. And that was when they launched the International Cloud Atlas again, a new edition of it. And the Asperitas cloud was the first new classification since 1951. Thank you. And it's not even as if this is a new cloud. It's always been around, but we noticed it because of technology and because of something like the Cloud Appreciation Society. In fact, you can see in 1835, I think Caspar David Friedrich painted the Asperitas cloud. It's pretty similar in this painting here. It's not so different from the cloud itself, is it? And then finally, I'm just going to end with, I know we're running out of time. Okay, I'm just going to end with the fact that maybe even there is some more changes. Yeah, I hope there's no one from the WMO here, because they might get angry. What about this one? It looks kind of like eyebrows. In fact, I asked a Latin scholar, what's the Latin for an eyebrow? And he said, supercilium. It's a bit weird, but maybe. You never know. I mean, some of the names are weird. Uncinus, that's a bit of a weird name for the hooked cirrus. Supercilium, maybe it's quite helpful to have a new name for this type of cloud, because it forms downwind again, that same place that lenticularis clouds form. They're in that smooth wave of air. Well, here is where the air of this cloud, where the flow of air tumbles and breaks, and so it's very turbulent. These clouds form in turbulent air is what seems to be the case. And it's pretty useful for a glider pilot, for instance, if they can see these clouds and they know the air is tumbling and turning there. Stay away from that type of region. And you sometimes see them with lenticularis clouds. Here we've got that cloud iridescence again, sunlight shining through the cloud. You've got a lenticularis cloud here, and you've got the eyebrow features. And this was spotted by a member who is on a hike in the Himalayas of Nepal, Mount Manaslu. And he said they had been on this hike, and this was the first time they got a glimpse of the mountain, this kind of iconic mountain in the Himalayas. As they entered this village, they looked and the sunlight was shining through. And here's a little video he took of it. Everyone in the village had come out, these people who lived there all their lives, and they were all amazed by the way the sunlight was shining through, producing these beautiful optical effects of the tiny droplets in this cloud with these eyebrow effects. And the members of, some of the members in the village said, I lived here 50 years and I've never seen anything like it. It was a really beautiful example of the Asperitas cloud, of the maybe supercilium cloud. Watch this space, or watch this blue sky, I should say, maybe. We'll see whether anything happens about that. It has been proposed as a possible one to do. So I'm going to finally end. When you've got a society that is about something as light and fluffy and airy-fairy and ungraspable as clouds, you've got to have some solidity to the situation. So right early on, when I started the Cloud Appreciation Society, I wrote out the manifesto of the Cloud Appreciation Society. All right? And it is 50 pages long. No, it's not, Derek. It's one page, it's only one page. We believe that clouds are unjustly maligned and that life would be immeasurably poorer without them. We think that clouds are nature's poetry and the most egalitarian of her displays, since everyone can have a fantastic view of them. We pledge to fight blue sky thinking, wherever we find it. Life would be dull if we had to look up at cloudless monotony day after day. We seek to remind people that clouds are expressions of the atmosphere's moods and can be read like those of a person's countenance. We believe that clouds are for dreamers, and their contemplation benefits the soul. Indeed, all who will consider the shapes they see in them will save money on psychoanalysis bills. And so we say to all who listen, look up, marvel at the ephemeral beauty, and always remember to live life with your head in the clouds. Thank you very much.
Ladies and gentlemen, Gavin Pretor-Pinney.
Okay. Cheers, thank you.
I always love hearing from our audience, but I have to admit to being torn. I could have done another 15 minutes of that. It was just phenomenal. Thank you. But we would love to hear from you. I know you've seen some incredible clouds. I'm sure there are good questions out there. A couple quick things. I'll bring the microphone to you. Please speak into the microphone and not near the microphone, because that's not how microphones work. So, in order for the room to hear your question, for Gavin to hear, and for our online audience, speak directly into the microphone. Stand if you're able, and so that we can get to as many questions as we can, get to your question as quickly as you can. Who'd like to get us started?
I've answered everything. I answered every. Oh no, down at the back.
All right.
How has global warming changed cloud watching, and do you think any new clouds have come from changes in the atmosphere?
So the first bit was how has global warming changed cloud watching, and then what was the second part?
Has it, do you think, formed any new types of clouds?
Yeah. Okay, thank you. So she's asking global warming. What is the effect that's had on the cloud formations? Has it caused any new forms of cloud? I don't know if it's caused any new formations of cloud. Not aware of that. But how global warming affects the clouds is a massively important question. A question that is being researched in a number of ways with a huge amount of effort by climate scientists. And the reason they're interested in how clouds might change in a warming planet is because they have a lot of potential for feedback. And that is because clouds don't change temperatures down on the ground in a straightforward way. The low clouds, like those Simpsons cumulus, or more importantly, some that have joined together, which would be called stratocumulus, when they're clumps in a layer, those have a very cooling effect on the ground below. Because they reflect away a lot of I said they look solid. That means they reflect away a lot of the visible light from the sun. And that means they have a cooling effect. You can feel it when you're sitting out and a cloud comes between you and one of those low clouds. You feel the difference. And they don't reflect that much of the Earth's heat back, but they reflect some back, but it's much more reflecting away rather than trapping in. The high clouds, however, the cirrus clouds, or if those cirrus have spread out into a layer that we would call cirrostratus, those have a warming effect. Because they're transparent or translucent. We can kind of see through them. They're subtle. The visible sunlight and the ultraviolet comes through, but they still reflect back the Earth's. So they have this greenhouse effect going on. They warm, the bottom one's cool. Nobody knows what will happen in our changing climate. The overall effect at the moment, a 2017 study in a paper called Nature Climate Change, which is a kind of classic study with an enormous amount of data that it was correlating to find the overall effect globally of clouds, concluded that per meter squared, and you do it in terms of watts because there's energy over time, per meter squared, 46 watts on average across the globe is reflected away by clouds, i.e. reflected back up of the sun's energy, and 28 watts of the Earth's energy per meter squared is reflected back down and trapped in. So the difference is they're reflecting away 18 watts, all right? So currently, the overall effect is of cooling the planet. Say we get fewer low clouds in the future, or more high clouds, that overall budget might well change. And there are some studies in 2021 that are all based on computer modeling, but all based on how when you computer model the clouds over the open ocean, which is when a lot of those low stratocumulus clouds form, they can be fewer in hot conditions. The ocean surface is hotter, general warmer air, and it's just talking about the weather, but there are fewer of those clouds than in cooler conditions. So the theory is, if you get an average warming, you don't have so many of those low clouds. Same as another study found potential for more high clouds. So unfortunately, there is a possibility with a warming climate that the cloud structures change, the distributions change, and we get a warming rather than a cooling effect. So there you go. Not great news. Yeah, down at the back there.
I am curious, how does the cumulus nimbus clouds create tornadic activity?
Yeah, right. So how does a tornado form from a cumulonimbus storm cloud? Well, thank you for that. It's certainly not your average little one. We all know that it's a large storm cloud that is going to be the first thing you need for a tornado to happen. You also need what's known as a mesocyclone, which means the central base of this cumulonimbus storm cloud has a kind of rotating quality to it. And you see this in time-lapse from the storm chasers. You see some amazing ones. Michael Binsky, for instance, is an amazing time storm chaser who's member 47 or something of the Cloud Appreciation Society. He does these amazing, you can see this rotation of the base of the storm cloud. Now, that is called a mesocyclone, and that rotation happens by the way the air is brought in, because this cloud is sucking air up into it. It's kind of like an enormous funnel of rising air, a storm cloud, because every time a droplet forms on what started off as a thermal in an unstable atmosphere, every time a droplet forms, it releases a tiny bit of heat. But if you have billions of droplets forming and the water condensing, that heat all adds up, and it keeps making the cloud more and more buoyant and lifting higher and higher and spreading out. So you have this rushing of air. If the surface winds are such that, a little bit like a kind of just you on the water of your bath, you just swish the water this way, you get the swirl happening as the water goes down the plug hole. You just need to kind of swirl in the winds near the ground to set up a motion of rotating. And then there's one bit on the base of this enormous rotating base of the storm cloud, which it has a name, the wall cloud, or murus is the Latin name, and that's a bit which extends down. It looks like it's sort of sticking down, and it's where some of the moisture, where all the precipitation is happening elsewhere. So you've got the dry area where air's sucking in, and you've got precipitation happening over there. Some of that moisture gets drawn back from all the rain or the hail, all that coming down gets drawn back, and that adds even more power because there's even more moisture, even more condensing happening. And there, that wall cloud that extends down is the birthplace of a tornado, because within that you can get this extra boost of rising power, which can set the speed of that rotation locally much, much stronger. And you have a finger of cloud known as a tuba. It's like a finger that extends down from the base of this murus, because within the spin, the air pressure is lower and it cools, and the droplets form within the spin. It joins with debris arriving from the base. The two join together, and if the speeds are high enough, the wind speeds are high enough, you've got a tornado on your hand, and it can take on a whole range of different forms as it travels over different terrain, as the cloud develops or wanes. There's a whole, you've got all these different rope tornadoes, depending on how that spinning effect happens. And it's like water going down a plug hole, except it's air going up, and it's not water, and it's an enormous storm cloud, and it can take the roof off your barn. Okay? Okay, thank you. Yeah.
Thank you. Very interesting. The ephemeral quality of clouds, it's fascinating. But I've heard of some things with microplastics being found in clouds. If you can talk about that a little bit. And then on the other end of the spectrum, is there any biologic elements in clouds or found in clouds?
Yeah. Okay, great question. So I've been talking about air cooling and there being moisture in the air, all right? And that's where you need to make a cloud, because you have water vapor is a gas, like we have in every breath we're breathing out right now. There's got water in it, just a gas form of water. And when it condenses into droplets, we'll see it as a cloud. But actually there's another ingredient that's required to make a cloud, because water vapor in a bit of air that's cooling, if the air is completely clean and is devoid of any tiny particles of dust or salt or soot or volatile chemicals from plants and trees, if it's devoid of everything, very clean air, then the water droplets won't condense. Not until the air is it's 42 below Fahrenheit, round about that, minus 42. Only then will droplets tend to form and freeze. That's definitely when they freeze. Actually, it might be a little bit higher than that when it comes to condensing, but it's very reluctant, water to form into droplets, unless there's something for it to get started on. So particles in the air are a crucial ingredient that is often forgotten in the formation of clouds. And you can find them from pollution, or it could be from a forest fire, or it could be from salt from the breaking waves at the shore. There's tons of dust in our atmosphere, too small for us to see, but definitely that can work as the seeds, the condensation nuclei onto which cloud droplets form. And beautifully, some trees give off these volatile chemicals, and you see this over the Amazon, releasing huge amounts of these, what end up as little kind of seeds onto which droplets can form. But of course, they could be anything. And yeah, pollution, I guess microplastics would be included in that. Anything small enough can act as a seed. But, you know, the clouds do have a good effect of bringing them down to the earth again. And they have this kind of air clearing quality because the droplet forms. And if the cloud grows into a rain cloud and produces rain or snow, it's going to bring them back down. So it does have this. I think our atmosphere would be unbreathable if we didn't have clouds bringing the particles back down again. You also find living organisms in clouds. And I won't go, it's called, these organisms, there's a theory that these organisms have evolved to encourage the cloud to rain. And this is a theory known as bioprecipitation. And you can Google it, and it's an area of research. These would be single-celled organisms like bacteria. And these bacteria will grow normally on the leaves of plants. And they are, it's called syringae, I think is the Latin name for this Pseudomonas. Syringae pseudomonas is the Latin name for a particularly good one. And they grow on the leaves of trees, and they can't get the nutrients in the leaf because the leaf's kind of quite well evolved to stop getting the goodness from bacteria getting it out, unless there's ice on the leaf, and it kind of breaks the cells, and that's released it for the bacteria. So they have evolved to encourage droplets on leaves on frosty, cold mornings to freeze. The leaf is trying to do the opposite. It's got oils on there to try and discourage the water droplets on its leaf from the sort of dew, discourage it to freeze. These ones encourage it, and these, when the leaf dries out, get wafted up in the air, like this, and float up in the air like everything else that's floating around, and they have been found within rain falling from clouds. And the theory is, maybe this little evolutionary advantage they had to make freezing happen on a leaf also helps them land somewhere else. Because the beginning of rain in a cloud is when the droplets in the upper reaches of this cloud cool enough to freeze. And that's an important thing happens. When they freeze, only a few of them freeze, because maybe only a few of the right sort of particles are there to act as the freezing nuclei, which is slightly sort of subset of the cloud nuclei. And the freezing ones might just happen to here, and over there, and over there, and over there. And when one freezes, it holds on to water, the water molecules, more tightly than the droplets, and therefore it sort of robs the surrounding droplets of water and freezes and grows, and you get lots of tiny droplets that were too small to fall because they were just wafted by the air, turn into fewer ice crystals that are big enough to fall. So you have the beginning of precipitation. And as they fall, they might melt, land as rain. So that encouraging a droplet up in the upper reaches of a cloud might be the way this bacteria comes back down to land. So it's a long answer, wasn't it? So yeah, there are living things in clouds, if that was what you were wondering.
I don't know if we have any Vail Resorts engineers in the house, but someone's listening. We're at our time, but there was a question online that I thought was quick and kind of fun. We have an audience that loves to travel, and we travel for amazing natural things. We travel for cuisine and experiences. If our audience had the ability, where should they go to see the world's greatest clouds?
Well, firstly, they need to sit in the window seat of the plane. I mean, that is very important. This is just flying over. Can I get this to go? Is this going to go? Maybe not. No. Oh, there's a video it's not showing. Anyway, but the first thing, most important, is to get the window seat. There you go. That was just me flying over again from Missouri when I was looking out the window. You see the most amazing cloudscapes. You don't have to go too far. You can just start while you're still on the plane. But I mean, anywhere mountainous is great, you could, you already live in a fantastic spot. I mean, maybe you need somewhere with a few more clouds. So maybe the Alps of France and Switzerland are always great places to watch them. I once traveled across the world to Australia to see a cloud that looks like a long roll, which glider pilots surf, like surfers on an ocean wave, in the wave of air. So you could do that. Really, the most important thing is not going somewhere, because if you travel somewhere to see a cloud, you're pretty likely to be disappointed. I mean, they don't do what we want them to. They don't appear on demand. That's why the sky is so interesting, because it is the most uncontrollable, ungovernable part of nature. So the best place to watch clouds from, and the best place to go for cloud spotting, is in your backyard. It's all about perspective. It's changing your relationship with the sky so that you don't look around at your feet. You take a moment each day to engage with the beautiful show that can be happening up above you. It's a frame of mind, and you can do it from anywhere.
Beautiful. Thank you. Gavin, Pretor-Pinney.
Okay.